In this short video, I'm going to talk about an ActiveScale technology called DDR. DDR is ActiveScale's out-of-band intelligent dynamic data monitoring and proactive repair processes. Traditionally, detecting data inconsistencies, also known as silent corruption, could only happen by deliberately interrogating the file or object. In other words, the inconsistency would remain hidden until you actually needed to access that file or object. So some very expensive measures were created to guard against that. Maintaining several copies is a common approach, which requires 200 or 300% more storage than you need. And that just reduces the odds of data loss due to the inconsistency, but still doesn't give you the ability to detect the inconsistency until the file or object is accessed. ActiveScale's DDR is a smarter way to detect and protect against data inconsistencies without the need for multiple copies and requiring very few resources. To better understand where DDR comes in, we need to do a quick review on how data is placed in an ActiveScale system. When you store a file in an ActiveScale system, it isn't stored as an individual file. It goes through an encoding process, and the result of that encoding process is an erasure-encoded object, in this case with 15 parts. Then another ActiveScale technology called DDP comes in. And DDP will intelligently place the object parts in the most ideal locations to protect against hardware failures, resource contention, I/O hotspots, and the like. And there are videos on our website that go into greater detail about ActiveScale's erasure encoding and DDP technologies. So I encourage you to take a look at those as well. So where does DDR come into play? Underneath the covers of ActiveScale, there is a distributed file system. Now you can think of these object parts as individual files stored on that file system. And these files or object parts have metadata, so they're smart. DDR is out-of-band processes that work on the object parts. They use the metadata to detect and repair inconsistencies. Let's take a look at some of the metadata. We know the file name. We know the parent, and this would be the name of the original file that came in and was erasure encoded. We know the bucket Sally's spreadsheet is in. We also know a sequence. When Sally's spreadsheet was originally encoded, that process produced 15 object parts, and this part we're looking at is number 5 of the 15. We also have a hash, and this is the hash of the object part itself. Now this is only some of the metadata that is associated with the object parts, but the point is, we not only maintain intelligence at the object level, we have intelligence at the object part level as well. So let's take a look at how some of this metadata is used. DDR processes. They systematically look at these object parts and verify the metadata is consistent with what's in our databases. In this case, we have the file name, the parent, the bucket, the sequence, and the hash. But we do one more check. Let's verify the part itself is consistent. Now we know originally that part hashed out to 4723. So we can take the part, run it through a hash function, and confirm consistency. So to wrap up monitoring, ActiveScale's advanced erasure coding creates smart object parts with metadata. The metadata is used to detect inconsistent object parts. And DDR are the out-of-band processes that verify metadata and the data itself are consistent. Now let's shift to proactive data repair. These processes are going through the system looking at object parts. And they run continuously. And because they run continuously, the processes run at a very low priority to ensure they do not interfere with regular system I/O. In a real system, there will be thousands of disks and billions of objects, so you're going to need more than a few of these processes. You can think of it like a little army of these processes that continuously run around the system validating object parts. But what happens when an inconsistency is found? In this case, during the monitoring, we discovered that the data itself was inconsistent. The hashes didn't match. So how do we fix that? Well, we know this object part came from Sally's spreadsheet. We know it was part number 5 from the encoding process. And we know its file name. Sally's spreadsheet is still safe. The nature of erasure encoding ensures we can get an object back even if we lose several parts. So all we need to do is reconstruct Sally's spreadsheet by decoding the required number of parts. Then we take Sally's spreadsheet, run it through the encoding function to get the original 15 parts. It would be easy to just write the parts back out to the distributed file system, but in ActiveScale, the object parts are smart, so that would create unnecessary I/O. This is where some intelligence comes in. We know we need sequence 5, and we know its file name, so we can simply discard the unneeded parts, write this part back to the same or a different hard drive, and we are now once again consistent. Quick review. In ActiveScale, object parts are smart. They have metadata. DDR is the out-of-band processes that continuously monitor the parts for consistency. And objects are repaired by overriding only the damaged parts. For more information on ActiveScale and DDR, visit our website.